You are welcome to today's class. Today we'll be talking about divergence theorem and Stokes theorem. So from there we moved into tensor analysis. But let's quickly start. Share my screen. So can you see my screen, please?
I can see, sir.
Okay, good. So let's start. For divergence theorem, there are things that are involved. Let's look at the definition under it, then the solution. We have the definitions to be. We had the dive of vector field multiplied by VF, which is dive F is the same thing as partial derivative of P over the X plus partial derivative of Q over the Y plus partial derivative of Z over R over the Z. So, and there's theorem that says in the theorem said let S be closed piecewise smooth surface which is the boundary of V with normal pointing outward So now we say let's our F volume, our F feed, vector feed equals to P, Q, R. They all belongs to this particular group on a region containing V. Then the formula will be, we have this double integral, which is surface. You remember F of this multiplied by the S. So, and it's the same thing equals to triple integral, which is volume of depth dot F vector the X, the Y, and the Z. So what I will say, let's look at the example when it comes to divergence theorem. Certain things needs to be involved. So let's look at this. Example 1. So we have F of x, y, z equals to 4xi minus 2y squared j plus z squared k. They all belongs to this region. And the S is the cylinder. S is the cylinder. X squared plus y squared equals to 4. And we have the interval of 0 less or equals to z less or equals to 3. So for us to solve this one, we need to remember the theorem. The theorem says, look at the theorem. So let S be closed piecewise smooth surface which in the boundary of V with normal pointing outward. So you first of all draw what we call our cylinder. Let's sketch the cylinder out. So let's look at the way the cylinder look like here. So here we have it to be 3. Let me just do it this way. So let me just draw it in a normal day. Let's first of all get our cylinder right here. Okay, so we have Z here, we have our Y, we have our X here. So don't forget the upper limit here is what? This is from 0 to 3. So all we need to do, let's write, the solution now started. We need to find the flux of F going out of the X using Gaussian theorem. So when we said Gaussian theorem, is the same as Gaussian divergence theorem. So the Gauss theorem is, we said, let's find the flux of F. Let's find the flux of F going out of X. This is our X, so it's X, using Gauss theorem. I can put Gauss here, you can just put Gauss here. So using the Gauss theorem, then we have the formula to solve it to be in this form. We know is the surface integral here, double F dot the x. We did this one before, so I believe we still know it. Please, if you don't know it, please refer to your books. They are all there. So if you look at this theorem, this is what we're trying to work on. So we know that the x, the y, the z. We know that we can, first of all, solve this one, dot f. So, which is the same thing as the p, the s, plus the q, the y, plus the r, the z. We know our f from day one to be our f of s, y, z. It's the same thing as 4xi minus 2y squared j plus z squared k. So if you want to solve this one now, using this method to solve this one, so what are we going to have? Our df, our def f now will be what? Differentiate this with respect to f now. What do we have? Well, differentiate this with respect to, this is our p, this is our q, and this is our r. So we differentiate this with respect to s, you have 4 minus. When you differentiate this one with respect to y, you have 4y, and this with respect to r, you have 2z. So I can go ahead and substitute it into my integral formula by saying that I'm going to have integral of triple integral, because I'm solving it from the other side. But let me write everything here. This is s dot dx. It's the same thing as triple integral of 4 minus 4y plus 2z dx, dy, dz. But at this point, we need a kind of change in parameterization. We need change variable. We need to do what we call the change variable, change of variable, and parameterization of the word parameters. Parameterization here. So what do we do? When you are working with cylinder, how do we change the variable in cylindrical coordinates? Please, you need to learn all this. They are very vital. For us to change from cylindrical coordinate is, we said let x equals to rho cos psi. Then our y will be rho sin psi. Then the z will remain z. Z will be z. So I'll put the notes here, changing variable to cylindrical coordinates. So changing variable from cylindrical coordinates. And don't forget, in this case now, anywhere you see x, we have 3 integral now. We have 4 minus What do we have here? 4y. What is y? Substitute the y here. Some people use theta. Anything, you can use any other things you like. 4 rho sin psi plus 2z, because z is z, but multiplied by Jacobian, which is j. So our j in this case is rho. The rho. Some will say the theta is still the same thing. Don't forget. So we have the rho. Then the second one will be with the psi, and the third one will be the z. Since we have 3 integral, so we have 1, 2, 3, just to initiate the problem we want to solve. But in this case now, I can do it this way. The first one, the limit will be from 0 to 2, while the second one will be also 0, which is psi. We're talking about circle now, because what we are given is in form of circle equation. You remember this? Hello? Are we there?
Yes, sir.
Okay.
Yes, sir.
Remember that this is more or less it's a equation of circle. Remember, a circle say x squared plus y squared equals to r squared. So we can make this one 2 raised to power 2 in order to be in r squared this way. So we can continue. So from there, we can substitute our value. So when I'm working on the row, so it will be from 0 to 2. Then when I'm working from here, is complete rotation, which is 2 pi. And the last one, which is our z, it will be integral of 0 to 3, because we are given the, look at it, we are given the limit for z already. So the rest, we just calculate the rest from based on here. That is where you have x, where you have y, what is the x. Although you can also solve this one by making y subject of formula and making making x subject of formula, and you find the square root, you substitute it. So it's also possible. So now we'll choose this one. We can continue by saying, let's integrate this. But before you integrate, there is a problem. You have to open the bracket with this. Although you can open the bracket along the line, it doesn't matter. So let's do it along the line. I'll just open it. I'll say, okay, we have 0 to 3, then 0 to 2 pi. So I'm integrating this first one now. So it's going to give me 4 root over 2, because I've already used this one to multiply this, and I'm integrating with respect to rho. So 4 rho over 2 minus, so how do we integrate this one? So I'm going to be minus 4 rho cube over cube, because this one has already turned to 2. Because when you open the bracket, this one will turn to 2, plus 2 z rho squared over 2. The limits are 0 to 2, the psi, and the s, the z. So this one cancel this, it means 2. This one go with this. So at the end of the day, I have what do I have? I have 0 to 3, 0 to 2 pi. So you have 2 rho squared minus 4 rho 3 over 3 plus rho 2. When you substitute 0 there, everything will turn to 0. This one has a sign, sorry. So at the end of the day, we have the xi, the z. So we need to also solve it now. Let's integrate with respect to psi before we substitute our value. So how do we solve the psi? Anybody? How do we solve the psi? So we can go ahead and substitute the one of xi. It's very simple. Let's integrate. Integral of 0 to 3. So it's going to be 0 to 3. Then when you integrate this, what do you have? If you integrate it very well, you are going to have 8 minus 32 over 3 sine psi plus 4z plus 4z dz. So if you integrate this one very well, then when you now substitute, now we are left with this.
Sir.
Yes.
Are we going to input that 0 to 3 on the last
Yes.
Yes, sir.
Yeah, no, we will integrate it and equip it. But before then, there's something common here, 2 pi. Remember, we are substituting 2 pi here. I've already do the substitution here. You can sit down and do that one on your own. Just integrate this one and substitute 2 pi into it. Remember, when you substitute 0 here, is 0, this one returns to 0. Because we are actually substituting our value into the psi. Into the psi. Psi contains that. So this one turns to 0. Because where you said sine 360.
To 0, sir.
Yeah. Sine 360.
Everything. Is everything there that turn to 0?
No. It is only when you substitute what is sine 360. What do you have?
0.
Yes, that's why this one turns to 0. We've already factored 2 pi out of it. Remember, upper limit minus lower limit. But by the time we are substituting upper limit, we notice that 2 pi is involved. Pi is involved. So remember that when you integrate, this is the only way that you will. When you integrate, what happened to this one? There's nothing you do with them. So that's why when you substitute pi, you have 0. But let's integrate the last one with respect to z. Are you getting me now? Do you want me to come again?
Yes, sir. Yes,
you want me to come again? You know when how do we integrate this one? I'll just do sketch here. Is 2 rho 2 psi. That's the meaning. Minus. So when you integrate this one, what do you have? Remember, you have it psi. When you integrate psi, what do you have? When you integrate sine, what do you have? When you integrate sine, what do you have? You don't know, please find out. Then when you integrate this one, find out. Plus, when you integrate this one, what do you have? This is 4 psi this. and I have 0 to 2 pi. If I substitute 2 pi here, that's where I factorize this one out. So at the end of the day, you have this. So we have 2 pi integral of 0 to 3 in bracket 8 plus 4z. So when you integrate this one and you solve it very well, you are going to have 84 pi. You are going to have 84 pi. So I want you to go and solve it. And get your final answer out of it. So let's look at that's all about divergence. You can lay your hands on some of the examples in your notes, and you will also have the same answer. All you need to do is just to follow the method, substitute the formula there, then integrate them. So let's look at the Stokes theorem. Under the Stokes theorem, there is a bit different. What is different with Stokes theorem is the formula, nothing more. It's the same formula that we are talking about. So when they ask you using Stokes theorem, please know the difference between all of them. All of them they look alike, but they are not the same. Are we there now? Do we continue?
Yes, sir.
Stokes theorem. So on the Stokes theorem, you have the formula says integral of line integral of C dot dr equal to surface integral call f dot df. This is surface integral. So that is all about Stokes theorem, which means you have S is an oriented smooth surface bounded by a simple closed smooth boundary called C with positive orientation. So all I need to do is just to look at the positive orientation. But let's look at the question first. Then from then we can solve. Look at the example. If you want notes, you can look at the notes in your textbook. Find collect the x. S is the hemisphere. X squared plus y squared plus z squared equals to 9. And our z is greater or equals to 0. Meaning upward orientation. So our f in this case, x comma y comma z, same thing as 2y cos z I plus e of x sin zx j plus s exponential y k. So we had this. Let's solve solution. Remember your formula that says integral of is equals to integral of c so our c is disclosed is what? X squared plus y squared equals to 9 because z equals to 0. Remember, they gave us the condition z is either greater or equals to 0. So choose the z equals to 0 so that we can have our circle. Then in this case, we need our parameterization or in this case. Remember, circle is what? Anytime you mention circle, they are talking about, they say t tends to 0, 2 pi. That is circle. And our circle is what? X squared plus y squared equals to r squared. So in this case now, we can have x squared plus y squared equals to 3 squared. But for circle, if you want to parameterize, so we have parameterization, we have our x to be equals to r cos t, y to be equals to r sin t. What is our z? Our z is equals to 0. So I can go ahead and substitute this. I will now have r of t to be the same as d dx, d dy, d dz. D dz. Sorry. So now I can substitute the r there now. What is my r in this case from this formula? What is our r, please? Anybody? Remember I told you, remember it's 3 raised to power 2 for the entire one. So this is 3 sin t. Any question? So we can go ahead and substitute it here now. I can say r of t is equals to 3 cos t, 3 cos t, and 3 sin t. Then this is 0. So if you now want to differentiate it with respect to individual, with respect to t, rather, we have r of t, r prime of t is equals to, when you differentiate cos, what do you have? You have minus sine. So you have minus 3 sine t, comma. Then differentiate sine, you have cos, 3 cos 3, comma. Then if you differentiate 0, you still have 0. So I can substitute this one into my equation by saying 5 f is equals to bracket r of t, which is the same thing as you multiply r of t multiply by difference, the r we have, the equation we have. We know our f, we know our r, so we can multiply them, do the dot product to them. Our r is here, and we have the mandate from the. So let's write now. It is simple now. Let's quickly write. What is our f? F is the question we are given. Can you see the question? This is what we are given. So we now said f multiplied by r of t now. So we're going to have 2 in brackets 3 sine t, then multiply by, remember this is containing, we already substitute this, we need this. Multiply by z, our z, cos z is what? Cos 0. That is a, remember our z is 0. Then we have e raised to power 3 cos . So at this point, what do we need to do is e 3 cos t, then dot sine 0. Then the last one will be 3 cos t exponential 3 sine t. So which is going to be, cos 0 is 1, 2 times 3 is 6. So we have 6 sine t, comma, all elements in z in middle now returns to 0 because sine 0 is 0. And then we have 3 cos t exponential 3 sine t. So any question? So in this case now, we need to now integrate. The formula is integral of 0 to 2 pi f of r of t dot r prime of t dt. So we know our r prime dt dt, and we already have it here. So we can substitute the value.
Sir.
So, yes.
When we are inputting that value of X and Y,
yes,
we do not put a plus there. Is it not need yet?
We did not put
plus 2y cos I plus exponential X sine ZJ.
You see, each of them carry, it simply means, how do I explain it to you so that you can get it? Okay, we've now integrate. We are just only giving them compartment by compartment. We are just doing IJK. That's what we are doing here.
Okay.
Are you getting it? So it's only here we did the integration the other time. It's more or less like you have IJK. But don't forget, when they multiply, they say when you find it dot to dot for I, they will cancel. When you add dot to dot for J, they will cancel, and so on, I said.
Okay, sir.
Thank you. So we can go ahead and substitute into this. When you substitute into this, what do you have? We are going to have integral of 0 to 2 pi. Let's substitute. When you solve it very well, you have 18 sine t sine square t plus 0 plus 0. So at the end of the day, the t follows. When you now integrate this one, 0 to 2 pi, take this one out. Negative 18 is out. Then don't forget, you can split this one. What is sine squared theta? Sine squared t is the same thing as sine squared theta. You remember? Sine squared theta will now be, when you want to write it, to explicitly write it, you have 1 over 2 cos 2t. So I will substitute, I will replace sine squared theta or sine squared t with this. I'm going to replace them. So what do we have? So we will have here 1 all over 2 in brackets 1 minus cos 2t dt. So when you take this one out, what do you have? Take 1 over 2 out, you have minus 9 integral of 0 2 pi is integral of 0 to pi. So when you integrate, we have 1 minus cos 2t dt. So minus 9, let's integrate this, we have t minus 1 all over 2 sine 2t 0 to pi. Is 0 to pi. So if you solve it very well, what do you have? You will have negative 18 pi. Please solve it. All you need is just to substitute your pi inside. Any question? Okay, let's look at another one. In case they ask you to solve the curve, so let's look at it. Where is Nasiru? Is no more online. Kausara, how are you?
Good afternoon, sir. I'm fine, thank you, sir. Sorry I joined the class late, sir.
No problem. You're always welcome. Abiodun Oladejo, are you there?
Good afternoon, sir.
Good afternoon, ma. Adekoju Israel, are you there? Okay, let's continue. Let's look at this question. Find C integral, line integral of this, the R, where your C is the triangle with
Hello, sir.
yes.
Please, sir, before we get to that answer, where we have a minus 80 pi, I think when we differentiate cos.
Cos 2t.
Yes. I think it should give us a minus sign. Then we already have minus there. We already have minus before that. Minus, that is minus cos 2t. I think it should give us plus.
Plus, thank you. That's why I said go and solve it. Just substitute this. All you need to do is just to substitute your pi. And substitute your 2 pi. Are you getting it? And don't forget, the other sign side will be 0 or true. I hope you agree with me.
Yes, sir.
Then you have minus 18.
Yes, sir.
Pi. So that's it. Thank you. Is that Israel or Samuel?
Samuel, sir.
Okay, Samuel. Okay. So you have 0, 1, 0, and 0, 0, 1. C is counterclockwise. C is counterclockwise view from f of s comma y over z equals to s plus y squared I plus y plus z squared j plus z plus s squared k. So how do we solve this one? Recall that from the formula, we have the solution to be integral of C f dot dr is the same thing as surface integral called f dx. Now, we are talking about triangle here. Get our triangle from any angle, like triangle. So here is our z, here is our x, here is our y. So at this point, we all know that is 0, 0. So this one we have 0, 1. And here we call this one D. Here we have 1, 0. So let's continue. Let's continue. The core of f is defined as determinant matrix X, sorry, d the X, I, G, d the Y, K, d the Z. So we have it to be S plus Y squared, and J is Y plus Z squared, right? In bracket, Z plus S squared. Any question, please? So we can take first one. Let's say we're taking, want to work on I now. I will be, this one will cancel, and the row will also cancel, will remain what? It will remain d the I, the Y, and Y plus Z squared. And this will be d the S, d the Z. So d the Z into Z plus S squared I minus,
Sir, is it
yes?
only row that cancel there, or both row and column?
Both row and column. That's why we don't pick the X, d the X. Are you getting it?
Okay, sir.
The row, so you remember from the matrix, the way we normally do the determinant matrix is the same determinant method we're using here. So we will not
But
pick
I
the
think
Y.
it should,
You said?
I think you should complete 3 instead of using that I.
And that's why we use I to like complete 3.
Okay,
Are you
sir.
getting it?
Yes, sir.
I is just a coordinate.
Yeah.
Do you get
You
it?
know
Yes, sir.
that would be the X by X of Y squared and the Z.
So you do the DZ too. Excuse me.
Sorry, sir.
Plus J. This is J. Plus the K we cancel also. For the fact that we said the column K cancel does not mean you should not use K to multiply it. Are you getting it? So you have it to be d the X, S plus Y squared, then d the Y, Y plus Y squared. So let's integrate let's differentiate this one. Find their stuff. So this will do this, while this one will do this. So you can see. So the first one now, it simply means I'm differentiating with respect to Y. Do I have Y there?
No, everything will be 0, sir.
0 minus, we have Z here, 2Z.
Yes. Yes.
Are you following?
Yes, sir. I minus.
So when you do this one too,
We have 2x
this one will be
minus
2x
minus 0.
minus 0, J plus this side you have 0 minus 2y. So when you open the bracket, what do you have at the end of the day? So we are going to have minus 2zi minus 2sj minus 2yk. So which is the same thing as our pi plus qj plus rk. So you discover that the way it is will be the way you are going to use it. So this particular one is our core F. Anytime they ask you to find the call of a particular thing, you have to use determinant matrix to solve them. Don't forget our formula. We can now project by saying the call of X the S is the same thing as double integral of D. Our projection will be how do we do the projection here? Anybody? So don't forget we have it to be our P. Let's say we call this one G. Let's call this the entire G of X. Look at what I'm doing. I want to do it this way, minus P, this and this together. Let's call this one the S, no, the G. Let me call this one G. So with respect to G now, G with X, the G over the X minus, because it's negative here, minus our Q now, QJ, Q into the G over the Y plus our RDA, because it's still the same thing, because in this case, remember that we are going to make our Z from here, X plus Y plus Z equals to 1, which implies that what's Z here? Z will be 1 minus X minus Z. No, minus Y, sorry. So meaning that the G of X comma Y is the same thing as 1 minus X minus Y that we have. So I can easily go, you know your R to be 2Y. I can substitute it doesn't matter, but I don't need to differentiate it to pass through this G, X, and Y, because we are working in a two plane, which is X and Y plane. X, Y plane, that's where we are working on. So that's why you can see G, S, comma, Y. That's why I put this one as RG, RDA. So we can go ahead and substitute all those values here. The one we have in the bracket, number 1 for the projection, which is our D, is going to be negative. What is this one? So you have negative 2Z into negative 1 minus negative 2X into negative 1 minus 2YDA. So at the end of the day, when you open the bracket, you have this with me, negative 2Z, negative 2X, negative 2Y. The A is still the same thing you have up that we are still trying to substitute here into this particular category. So along the line, when you substitute what you have, some things will cancel out and some things will remain. What are the things do you think it will cancel out? Anybody? What is our Z? Who can tell us the Z? Remember, you know your Z here, from here.
1 minus x minus y.
Yes. So you can substitute the Z here. It will be -2 in brackets 1 minus x.
Sir, before you
minus y.
substitute, sir, how do we get that minus 1?
How do I get?
The minus 1 at the back of minus 2z, open bracket, minus 1, close bracket.
From here now. Are you getting it? All I'm just doing is I'm still substituting it. I just show you the way I got it. How this one comes. That's
Yes,
what I just showed. It's still, are you getting it?
Yes. I
It's
went
still,
to that minus 1. Yeah, yes. That double integral d minus, open bracket, minus 2z, close bracket, minus 1.
that is what I'm telling you. Okay, how do I explain so that you can get it right? Okay, look at the formula here. Look at what I put here. For transformation, look at it. For our transition, look at what I got here.
Yes, sir.
So if you differentiate your G, our G alone, when you differentiate the G dx, the G dx is what? Tell me the G dx.
Minus 2. Minus 2z.
No. Wait. The G dx is what? Because when you are trying to differentiate the G dx you have from what you have, what do you have? You have minus what? From here, please. From here, differentiate the G dx. What do you have? What I circled. The G dx in this case, you have -1. The G dy, you have -1. The G dz is 0 because you don't have it here. Am I right?
Oh.
So now if I substitute the G dx, which is -1 that I've calculated here, it will multiply. And I know my P to be -2z. So substitute -2z here, multiply by the G dz. Look at it. The G dx is -1. The G dy is also -1. But the G dz is equals to 0. So remember, I call this one G. Differentiate the G. I said Gs, y. Differentiate it. What do you have? This is what you have. Now, substitute it into this equation again. You have this one back. I hope I'm communicating now. Samuel. Okay, let's continue. So when you open the bracket with this, what do we have? Some things we canceled. You have, okay, let me write the rest. This is positive. I have -2x, -2y dA. So at the end of the day, let's open these brackets. You have -2, negative that's negative, positive 2x, negative that's negative, positive 2y, minus 2x minus 2y dA. This go with this, and this also follow this. So at the end of the day, you have integral of d minus 2 dA. So when you integrate this, you have it -2 outside. Integrate a dA. What do you have? Initially, when I first of all integrate this one, I will have -2 into a, because it will cancel. When I integrate again, what do I have? So at the end of the day, I will have 2, because we are talking about area now. We have -2 in bracket 1/2. So which is equal to -1. Any question? Are we there? Hello?
Yes, sir. Good afternoon, sir.
Good afternoon. I can see. So you are just joining us now.
Yes, sir. The network is poor, sir. I have to change my SIM card from MTN to Airtel, sir, before I'm able to log in, sir.
It is well with you guys. So.